Hello students. Today we will discuss chapter number 1, sets, concepts of sets, and our topic is a subsets of set of real numbers. This basic concepts of sets you already know in the standard 9, 10 in basic concepts. First of all, the set of natural numbers. Already we know these facts. Natural numbers 1, 2, 3, 4, 5 up to so on. All are the positive integers and you can call it natural numbers. There is no zero, no negative numbers, no fractions. Next is if you add in natural number, if you add some negatives, zeros and positives, and you will get the set of integers and you can call it capital Z. In integers including negative integers, zeros and positive integers. Next is the set of rational numbers. The set of rational numbers defined as a number which is you can write in a form P by Q form where PQ belongs to Z and Q not equals to 0. You can call it with capital Q, the set of rational numbers. Next is the set of irrational numbers. Means without all the rational numbers, remaining numbers are called irrational number. Irrational numbers are whose numbers without rational numbers and you can call it R minus Q. And you can define like this. T equals to X, X belongs to R, but X does not belongs to Q. Some important points are here as a subsets of real numbers. Natural number, the set of natural number N is a subset of Z. You can see it here. Set of natural number is subset of Z because all the natural numbers are belongs to the Z. That's why. Next is Z subset of Q, means all the integers are the subset of Q, means all the integers are the rational numbers, because in 2 you can write like this 2 by 1. It is the form in P by Q. That's why 2 is a rational number. That's why Z subset Q. This is the important point, and in examination point of view, this is important because in true false it is important. Next is Q subset of R. Every number is belongs to the real number R. That's why the set of rational numbers, all the rational numbers R belongs to the real number R. That's why Q subset of R. Next is T also subset of R. T is also the part of the real numbers. That's why T subset of R. All the irrational numbers are belongs to the real numbers. Next is N does not subset T. Why? Because natural numbers are not belongs to the irrational number. That's why N does not subset of T. Next topic is intervals as a subsets of R. This is the new for the 11th science students because this is the first time introduction. Open intervals, close open interval and open close interval. First of all, we will discuss one by one. First is open interval. Open interval means any number has some type of limits. Like you can call it, if you take the numbers between 2 and 10, you bound the limit here. If you are taking the numbers between 2 and 10, all the even numbers, and if you are putting in this open brackets, then 2 and 10 are not included on that list of numbers, right? You can write like this, and this is the general form. In general form, to write open interval AB equals to X colon A less than X less than B. Means A is not included on that list and B also not included that list. Means if you are write the list of all the even numbers between 2 and 10, you can write it's 4, 6 and 8. On the number lines, you can draw like this: A not included, B not included. Between A and B, all the numbers are included. Next is close interval. Close interval means colon A less than equals to X less than equals to B. Means that number, that boundary, starting point is included and ending point is also included. Which means if you are right like this, 1, all the numbers between 1 and 5, then you can write like this: it's 1, 2, 3, 4 and 5. There is 1 also included and 5 is also included in list out. And on the number line, you can draw like this: dark point, which means that point and that number is included, and this dark point, and you can call it close interval. Next is close open interval, which means one side close and one side open. Starting point is close and ending point is open. That's why starting point is included, starting number is included, but ending number is not included. Which means you can write in general form x colon A less than equals to X less than B. Again, we are taking some examples. 2 to up to 6. All the numbers between 2 and 6. Here, close interval with 2. Then 2 included, 3 also, 4 also, and 5. 6 not included, but 6 is not included because there is open interval. Next is open close interval, which means starting point is open and ending point is close, and you can write like this: x colon A less than X less than equals to B. On the number line, you can draw like this: A with a empty circle with point A and B with dark point, B included. And here we are taking example. Then you can write like this: numbers between 3 to 7. Here 3 not included because starting point is open interval. That's why 4, 5, 6 and 7. 7 is included on the ending side. Again, please remember this 4 intervals as subset of R. They all R belongs to the real numbers R. The set minus infinity to infinity. Please remember the set minus infinity to infinity describe the set of real numbers in relation to a line extending minus infinity to infinity. Already we know on the number line you have this side minus infinity and right hand side infinity and left hand side negative, and all the numbers are included in this intervals minus infinity to infinity. Next is the number B minus A is called the length of any of the intervals. Any of the intervals means this 4 intervals. If it is open, close, close, open and open, close intervals. Any intervals means if you want to find the length of any intervals, then you can just take difference of the B minus A. Again, we are taking some examples here right now. First of all, if we have to find the length of this interval, then B minus A. which means 10 minus 2. It's 8. Length of this interval is 8. Next is 1 and 5. It's 5 minus 1 is 4. Next is 1 and 5. Length of this interval is 4. Next is 2 and 6. 6 minus 2 is 4. And last one is 7 minus 3 is again 4. This is how you can find the length of any of the intervals. Next, universal set. Universal set, which means you can call it and take it as a parent set. The set of natural numbers. Here we are taking one example. The set of natural numbers and its subset, such as the set of all prime numbers. In natural number, we have prime numbers, even numbers, and so forth. All the numbers. They are the subsets. Okay, this basic set is called the universal set. Any set has its universal set, and you can write with capital U, universal set. Thank you. In the next video, we will discuss the next exercise and examples of this chapter, exercise 1.3. Please watch my videos. Thank you.